Somewhere in your kitchen right now, there's probably a bunch of bananas sitting on the counter, looking about as harmless as food gets. Yellow, sweet, slightly bruised on one end, exactly the kind of thing you'd pack in a lunch without a second thought. Here's the part nobody tells you at the grocery store. That banana is radioactive. Not in some theoretical, someday maybe way. Right now, sitting on your counter, it is actively emitting radiation, and it has been doing that since the moment it grew on the tree. Hi, I'm Potato, and today we're talking about something that sounds like it belongs in a horror movie but is actually just a normal, everyday fact about the universe, the fact that plenty of ordinary things around you, including bananas, and including you, are technically radioactive all the time, and almost none of it matters even a little bit. If this is the kind of thing that makes you want more science stuck in your feed, go ahead and subscribe because we've got plenty more of these seriously? Facts lined up. Anyway, let's actually get into why your fruit bowl is quietly glowing, metaphorically speaking. First, let's clear up what radioactive actually means, because the word tends to summon images of glowing green goo and nuclear meltdowns, and that's giving it way too much credit for most everyday situations. At its core, being radioactive just means an atom has an unstable nucleus, and that instability causes it to occasionally release a small burst of energy or particles as it settles into a more stable form. That's it. That's the whole concept. It's not inherently sinister. It's just physics doing what physics does, atoms rearranging themselves towards stability, and sometimes that rearranging involves shooting off a tiny bit of energy in the process. Now, bananas specifically contain a good amount of potassium, which your body actually needs for things like muscle function and nerve signals. But potassium isn't just one single, uniform type of atom. Like a lot of elements, it comes in a few different versions called isotopes, atoms with the same number of protons but a different number of neutrons. Most potassium atoms are perfectly stable and boring, chemically speaking. But a small fraction, roughly 1 out of every 10,000 potassium atoms, is a version called potassium-40, and potassium-40 happens to be radioactive. It sits there in its atomic form, slowly and randomly decaying, occasionally releasing radiation as it goes. Bananas are rich in potassium, so bananas end up containing a small but measurable amount of potassium-40, and therefore bananas are, in a very literal sense, radioactive. This isn't some fringe claim or internet exaggeration. It's such a well-established fact in physics and health science that there's an actual informal unit used to compare small radiation doses, called the banana equivalent dose, which measures how much radiation exposure you'd get from eating one single banana. Scientists genuinely use this as a fun, relatable way to explain how tiny most everyday radiation exposures actually are. Here's where it gets more interesting and slightly more personal. Potassium-40 doesn't only exist in bananas. It exists in a wide range of foods, and more importantly, it exists inside your own body. Your body needs potassium to survive, so you're constantly consuming it through food, and a small percentage of that potassium, following the exact same ratio as in bananas, is potassium-40. Which means, at this exact moment, sitting wherever you're sitting, there is radioactive potassium quietly decaying inside your own cells. You personally are emitting a small, constant, ongoing trickle of radiation, and you have been since before you were even born because your mother's body was doing the exact same thing while you were developing. This might sound alarming if you've mostly heard the word radiation used in scary contexts, nuclear disasters, radiation poisoning, that sort of thing. But here's the crucial detail that changes everything: the dose matters enormously, and the amount of radiation involved here is almost comically tiny. Radiation exposure isn't a simple yes or no situation. It exists on a massive scale, ranging from utterly harmless background levels all the way up to genuinely dangerous doses. And where something falls on that scale is what actually determines whether it matters. To put it in perspective, the radiation dose from potassium-40 in your own body is a fraction of what you get just from natural background radiation that exists everywhere on Earth, coming from cosmic rays constantly raining down from space, and from trace radioactive elements naturally present in soil and rock. Depending on where you live, you might get more radiation exposure just from the granite countertops in your kitchen, or from living at a higher altitude where there's less atmosphere shielding you from cosmic rays than you'd ever get from potassium-40 in your food. Flying in an airplane exposes you to more cosmic radiation than usual, simply because you're higher up with less atmosphere between you and space. None of this is dangerous at normal levels. Your body has been dealing with small amounts of background radiation for its entire evolutionary history, and it has repair mechanisms constantly fixing minor cellular damage as a routine part of being alive. The reason bananas specifically get singled out in this conversation instead of, say, potatoes or spinach, both of which also contain potassium and are also technically radioactive in the exact same way, is mostly a matter of banana marketing luck. Bananas are a widely eaten, universally recognized food, easy to picture, easy to joke about, and the phrase radioactive banana has a nice ring to it that radioactive spinach just doesn't quite match. But the underlying physics applies to anything containing potassium, which is an enormous number of foods, and to your own body, which needs potassium constantly to function. Here's a fun way to actually visualize the scale involved. If you wanted to get a genuinely dangerous dose of radiation purely from eating bananas, you'd have to eat an amount that's completely, physically impossible for a human to consume, somewhere in the range of tens of millions of bananas all at once, before the radiation itself became the relevant danger rather than, say, the sheer physical impossibility of eating that many bananas, or the potassium overdose that would kill you from an entirely different, much more mundane, non-radioactive cause. In other words, long before radiation became your problem, biology would have stopped you through completely ordinary means. This is actually a great real-world lesson in how science communication works, and how easily something technically true can sound alarming without context. Bananas are radioactive is a completely accurate statement. It's also, practically speaking, almost meaningless as a safety concern, because the actual quantity involved is so vanishingly small compared to what would ever cause harm. The same logic applies to your own body's natural radioactivity. Technically true, practically irrelevant, and honestly, kind of a neat party fact once you understand what's actually going on underneath it. So the next time you're peeling a banana, or thinking about literally anything else containing potassium, which is most of your diet, you can appreciate the tiny, harmless bit of physics quietly happening inside it, atoms of potassium-40 slowly decaying, releasing minuscule amounts of energy exactly the way they've been doing since long before humans existed, and exactly the way they'll keep doing long after. And you can appreciate that the very same physics is happening inside you right now, in your muscles and your nerves and your cells, a quiet, constant, harmless hum of radioactivity that's simply part of being made of the same atoms as everything else in the universe. This has been potato science, and honestly, that's the whole beauty of digging into stuff like this. Every ordinary object turns out to be hiding something genuinely strange if you just ask one more question about it. Catch you in the next one.